Hi everyone. So far we had an overview and introduction for Internet Computer Protocol, and we learned about many different concepts and how Internet Computer works on the background. And in this video we are going to dig deep on this architecture of Internet Computer. So what is waiting for us? First we have the explanation of the traditional network, and then we have a comparison between the ICP and the traditional network. Then we will talk about the core ICP protocol and the architecture of the Internet Computer. And finally, we will have our conclusion. So let's start with the explanation of the traditional network. Here in this example, as you can see, first we have our Wi-Fi, 5G or fiber ground. On top of it, we have the Internet protocol that is necessary for every action in the Internet happens based on this protocol. And on top of it, we have the cloud services. And on top of the cloud services, we have the databases or web servers. And only after that, we have our websites. But even after all these structures, we need to add the firewall to keep these attackers outside of our website. So as you can see, this is actually a multi-layer and a huge architecture that we are working with in Web 2. The general idea is that Web 3 can be a better technology, but everyone thinks in general that Web 3 is much harder to develop on and use. And we will see how we are actually making a system which is a centralized system, our current usage of the internet. We are going to transform this to a decentralized system with ICP by making it even easier for the developers. Now let's continue with the ICP and traditional network comparison. So traditional network is limited scalability, lack of security, and that's why we had this firewall and every possible integration we can find on the web servers and cloud services so that we can protect our website. The dependence on centralized servers, which is the obvious problem in Web 2, inefficient resource use, and finally, lack of interoperability. On the other side, on the Internet Computer Protocol, it's high scalable. We have chain key technology, as we talked on our previous presentation, which handles the security part for us. And of course, it's a decentralized technology and it can scale up and down using the network nervous system. Now let's look at the 4-layer protocol. As you remember from the previous slides, we had a huge architecture under our traditional network. Here we have 4 different layers: peer-to-peer layer, consensus layer, message routing layer, and execution layer. The peer-to-peer layer in the Internet Computer Protocol ensures secure communication between nodes within a subnet. It allows nodes to broadcast messages or artifacts to all other nodes, guaranteeing their delivery. Internet Computer Protocol uses a consensus mechanism to agree on and order messages. It provides instant finality, high throughput, and robustness, unlike Bitcoin's probabilistic finality. Internet Computer handles the induction and routing of messages between canisters potentially across different subnets. It ensures consistent message processing across all nodes in the subnet and enables inter-subnet communication. The execution layer is the top layer of the Internet Computer Protocol, executing Canister smart contract code using a WebAssembly virtual machine on each node. So, as a conclusion, the Internet Computer's architecture is powered by the Internet Computer Protocol consisting of 4 layers. These are peer-to-peer, consensus, message routing, and execution, which facilitates efficient blockchain operations. Thank you very much. That's all for this video. And in our next video, we are going to learn about our development environment. Thank you very much and see you there.